Alright, well, sorry for the shitty audio, but that's what you get. That's all I can say. So here's the host or the server. Here's client. Client asks for IP because I don't have Hamachi and my apartment internet has a lot of firewalls. I'm just doing local host for now. Let me just spell it right. Local host. Mash that enter button. Its server IP is set to local host. So when I actually call host and then I call join, it should connect. If I drive around, there's the fence hits persisting on both. There's fire persisting on both. And then there's the mines persisting on both. And just to show the score, so you can see the health and the mines are replenishing correctly. There's the lives decrementing correctly on player 2, and the score being kept properly. And there you go. Just to show the other side works. Here we go. So on wall hit. So there you can see it's decrementing. There we go. Switch back over here real quick. Just to get the full game loop. Go. Another kill. One more. Alright. There's 2 of 3. One more kill. Come on, one more kill. Kill after that, and it should say player 1 wins. That'll be the full game loop. Jesus. There you go, player 1 wins. Oh, I might have screwed that up. I did. So, essentially, if I mash the spacebar too fast, it'll start it up on the host side before waiting for this to actually reconnect and just still connect to the old instance. But nonetheless, that was the whole loop there. Just to quickly run through the code on what exactly happens. Server side, in game.cs, it's essentially hard coding. Where did I put it? Essentially hard coding the IP and server, or IP and port within network messages. This is the list of things to deserialize, even though in hindsight, all that really needs to be deserialized is player input, because that's all that's being sent by the player 2 or the client player. Game manager is extremely important in that its received message essentially takes it takes all the data that needs to be inputted. So if it's a network type for the message that's being sent, that means it's coming from the client, meaning it's an input message. Otherwise, the rest is your own player input or player update, meaning when you send it within game CS all the way down at the bottom, when you're checking for input, you send it to send type local, which then sends the input and then respective update. And then these are the processing things on server side. So there's the process game state, process input player, and then input player checks for the rotation, the move, if you've fired or if you've called lay mine, and it checks if it's either player 1 or player 2 that's doing that. Game over update checks for who won and then pastes based off that. There's the draws that you've given us, and then player 1 killed. I was testing some code earlier with this, and that apparently is just straight up wrong. Mainly in that it should the way I have it set up is player hit message sends all the score data, so the lives, the deaths, the kills, and the score to the client side to register and update in its own. There's mine destroyed, missile destroyed, which is called within the on hits. Fire missile called within missile itself, not missile itself, called shear to fire based off of the ship's rotation and position, which is here. There's lay mine based off position. Here's a cleanup code, display HUD and such. What's most important, I guess, is the input queue and output queue. So input queue, this adds it to the queue and then sends the message to client. The output queue here receives the data messages from the client and then calls Game Manager to receive it. And then so that's that there. And then that's deciding whether or not you're hosting and starting. Where we go. Client within the client version is slightly different. In the game.cs, we hold a static string for server IP and server port. Server port we're keeping the same because there were some weird discrepancies. So server port we're just forcing into the 14.240, which is default. But then we call the console write line for the IP address itself and read based off that line. Within the myclient.cs, we call network game.server IP and server port to connect to the utility, and if it fails, essentially, it doesn't connect. Here's the input queue, very similar, just sends a server instead. Output queue takes in receive message. This is old legacy code since it shouldn't matter on the type. You should just constantly call receive message. Game Manager is more interesting than the scenes or the servers, in that the receive message calls a different processor based on the type of message sent. So we have player input, game state, player updates, player attack, fence hit, collision, and player hit. Player hit message basically takes all the score data and applies it so it persists correctly upon two instances of server and client. Fence hit data cycles through the game objects and checks if it's a fence, and then checks if that fence ID matches the message fence ID, and then calls its on hit. Collision message works off an enum. If the enum matches ship, missile, or mine, it does essentially the same as the fence, but for those respective game objects, and calls their respective on hit code. Player update message updates the specific angle and position within either player 1 or player 2, depending on what the message contains and which ID is in there. This is the standard process game state message that sets the state to play, and here's the other version which sets the state to whatever the message state is, which is specifically used for when the game over state is sent in from the server side. Here's process input message, very similar to the other one, except it doesn't send attack messages to the server to render. It just sends the inputs that it called, essentially, or it sends your own input to show it on your screen what's happening. Here's player attack, which again just calls the fire or lay mine based off of what happened in input. Also based off of player 1 or player 2. Here's the game over update. Here's the draw, load screens, player kill. What's been switched is all the decrement and increment of the specific things are removed. All that's being called are the proper destroys and state calls to set it up correctly, and the respawns that to their respective spots. Here's mine destroyed and missile destroyed. Very similar to the other one. Not game object. Where am I going? Game.cs. I guess one of the main differences is instead of sending the player 1 message, it's sending a player 2 message, such that the server reads it and applies it all. I guess I could show you these. There's nothing really special here. What's more special is more so the server versions of the game objects. So like in fence.cs, if if there's an on hit call from the collision, it calls player on hit message to replicate it in the client version. Same with mines. Mines send out the where are you? Where are you? Where are you? Mines send out the collision message, which takes in their enum and their ID and sends it out. Same with missiles and ships. All their collisions essentially take their specific collision ID and sends it out. To be more specific, we go through all the data message real quick. So we have the game states, update, attack, input, collision. Sound isn't used since that's already implemented within their on hits, so there's no point there, and their destruction sounds. There's fence hit and there's player hit. In hindsight, I could have combined fence hit into collision, but that's past the fact. So first abstracted class is the data message, which just has its very standard serialized and deserialized for others to access later on. Oh, there's no deserialized, but either way, it's just an abstracted class for the others to derive from and call upon. Here's player input, takes the player ID, horizontal and vertical input, and then bools for fire missile and lay mine. These are basically called within the game to register your input, your keyboard input calls, and based off of those, it sends it via message, serialized as integers and bools, and then spat out respectively and applied via the game manager and the client. The game state is here, which sends and writes the game state you save into it, as well if it's networked or local. And this was specifically used in sending the game over state in server to match it in the client. Here is the player update, which takes the XY, player ID, angle, and then the fire, missile, and lay mine. Realistically, I could have taken these two out, but just for that extra added layer of protection, I have it also being encoded here. Oh, no, I don't. Oops, that's legacy. Don't worry about that. Anyway, so most importantly, ID, position in X and Y, and angle, which is saved and then applied to the update code, which applies their set pixel position and set pixel rotation. Player attack has the ID, fire, and lay mine. These are still written as bools, so these are specifically applied to the fire, missile, or lay mine methods based off of what's read and processed. Again, here's the fence hit. It just saves the fence ID to check against within the list of game objects. Here's the collision enums for ship, mine, and missile. Again, I could have moved fence ID into these just to keep it all, because they each contain an object ID and collision type, where the collision type is then checked, and then after the collision type is checked and it matches, it goes into the list of game objects to check against if they are of the same type, and if they are of the same type, it checks if they are of the same ID, and if they match, then they call their respective on hits. Then player hit message, again, keeps all the integers of the score, required stuff between 1 and 2, to send between player and client. And that is about it. Whatever's missing, I believe, is covered in the checklist. But yeah, thanks for class, Will. Might show you some weird networking stuff later if I ever get to it with the boys.